Yeah, we've all grown skeptical. What are you doing?
They're taking their card skills test.
This is next on the to-do list. So you spent some time, you've already taken a quiz actually on adding and subtracting rational expressions. And listen, quite frankly, the whole multiplying thing, probably the next time you see it will be like on a practice test, because multiplying and dividing polynomials, I believe, is something we did earlier this year. That's where you factor, if it's division, you copy dot flop, and then you just factor and cancel stuff out. Like with multiplying and dividing, you don't need a common denominator. So if it feels like we brush past that, it's for a reason. It's because it doesn't really deserve a lot of respect, and because I do think we've already talked about it. So rational equations are similar to the adding and subtracting polynomials, adding and subtracting rationals, in that we have to be aware of the common denominator again. So the first thing I wanted to point out to you is this, and this was not in the script here today, but I thought I should probably just say this out loud. If you had a question like this, x over a squared minus 4 over a squared equals 11 over a squared. Anyone think they know the answer? What is it?
X equals 15.
It does. X equals 15. And you think about an equation like that and you're like, what is going on? But what I wanted to get out of the way early here was to say this, that with equations, if the denominators are all the same, then the denominators go away. You don't need them anymore. They become redundant. And so if I give you x over something minus 4 over the same something equals 11 over the same dang something, then the somethings become meaningless. And we really are just working with this equation, x minus 4 equals 11. That's going to be sort of the predominant theme of the day here, is that I want to make my denominators the same so that they can just be ignored. And then that's where Brady presumably got the 15, is that now we just add 4 and we're done. So that's kind of the big overarching theme for today and probably tomorrow and who knows, whenever else. But this will take a little while. So let's get to it. So I got a bunch of examples scripted up because that's how I roll. So first one I got is negative 6x over x minus 7 minus 9 equals 3 over x minus 7. These problems theoretically throughout the lesson should start to get harder and harder, but I didn't actually work them all. I just plucked them from a resource. So your first thought is, okay, there's 3 terms to this equation. Whether they're on the left or the right doesn't matter, but there's 3. What is the least common denominator? Good. Yeah. So we've been down that road. So we know the LCD is x minus 7. And so our thinking at this point is, let's get this back to the way that first one was that Brady solved so quick. Let's get the bottoms all to be the same. So step 1, kind of a math 101 thing, is let's take that 9 and let's make it 9 over 1. Make sure you see it as having a denominator and a numerator. And then we'll just go right on down the line, fraction by fraction, and say, what does each one need? So what does the first one need? Nothing. Second one? And x minus 7. Good. So we're just going to feed it what it needs. And I will show it this time, but I'm not going to keep showing it. We are also, of course, legally multiplying on the bottom, right? But we just tend to let it go. And so the third fraction needs nothing. And so we wind up just saying, okay, goodbye denominators. And what we get is just this, negative 6x. What's this next part going to be? Yep. Plus 63. Good catch. Equals 3. I mean, that's pretty straightforward, right? Make the denominators the same and then ghost them. They're dead. And so negative 6x minus 9x is negative 15x. Subtract 63 to the other side. You get negative 60. X equals 4. Now, we're not out of the woods yet. It's not going to apply much all the time, but sometimes it does, and it does just enough that we have to be vigilant about this. In rational equations, you are, and you'll see it in the lesson today, from time to time, you're going to get numbers that actually don't work. And you might remember them from the past. They're called extraneous solutions. They're solutions that we get, and we didn't get them because we're wrong. We just get them and they weren't meant to work ever. So what we want to always do is just take a quick moment and check the number and make sure that it doesn't break any laws. And I'm going to say something, and if I have to recant this statement, full disclosure, I will take it back when I get a chance. But right now, I'm going to say this. I don't need you to do a bunch of math. What I need you to do for me is always check your numbers and see if they make any of the bottoms equal 0. Okay? And again, I'm going to work, I'm going to go home and Google this and see if I can find some examples of when what I just said is a lie. But I don't find that there are instances in which the number 4 doesn't quote unquote work. What I find is that answers sometimes make bottoms of fractions equal 0. And we're not allowed to have fractions with zeros on the bottom. So if you happen to get one, you would cross that answer off. But in this case, do you see how if you put 4 in place of all the x's, how nothing bad would happen? So we'll box that up and say, you are my solution. X equals 4. Okay.
We save it.
No solution. Sometimes, though, as you'll see, we're going to get quadratic equations. And with those, we might sometimes find that they both work, or maybe one of them works. And if they both don't work, then we say no solution, right? Okay. X plus 7 over x minus 6 equals 2x. What's step 1? Yeah, I would kind of say there's 2 parts to that answer. Like part 1 is let's take this x and make it x over 1. Let's take this 2x and make it 2x over 1. And for the rest of the lesson, I've got 2 or 3 more examples that have whole numbery kind of things like that. I'll probably just put them over 1 so we don't have to keep changing them. It's like when you copy it off of Delta Math or whatever, then you probably just put 1s to start. So what is the LCD? Perfect. So if the LCD is x minus 6, then we're just going to go and say, what does each fraction need? Like we've been here before. What does the first one need? It needs it. It needs the x minus 6. Second one needs nothing. Third one needs it. So whatever needs it, gets it. Whatever doesn't, we just ignore. Got it? All right, so now the bottoms are gone. Did I make that clear? We don't need them anymore. Once you make them the same, they just fall away. So the first part is right up here. What do we get? X squared minus 6x. Second part is just the plus 7 unmodified, doesn't change. And then we copy down our equals. And what's the last part going to be? 2x squared minus 12x. So here is the aforementioned quadratic equation, but we're not scared. Like we know how to deal with quadratics. So with quadratics, we want to pull everything to the side where the x squareds will stay positive. So I'm going to subtract this x squared over, giving me 1x squared. I am going to add the 6x across, giving me minus 6x. And then I'm going to subtract the 7 across, giving me minus 7. We recognize, as we always have, that with quadratics, we want them equal to 0 so that we can factor and then solve that way. So I've kind of warned you about this when you first learned it. The factoring just really never goes away. So let's factor this. What does it factor down into? X minus 7, x plus 1. So what are my x values? 7 and -1. And so again, let's just do our due diligence, take those numbers. And again, I'll come back to you and let you know if I find a reason to say we have to do more than this. But what I'm saying is let's just go see if it breaks any stuff. Do you see anything bad? I don't either. I don't see any places where a 7 or a -1 would make a denominator equal 0. Quite frankly, the only place of interest is in this green right here. It's the only denominator with a variable. And if you put either of those numbers in there, you don't get a zero, box it up, move on your way. Okay. ¿Qué tenemos que hacer primero? And before we find the common denominator, there's a little bit before that. What do we have to do first? Factor. You got to factor out that first denominator so that you can expose the LCD. What is the, say again?
It's X times X.
Good. So this first denominator is actually X times X plus 8. If I haven't made that clear, I have failed you as your teacher. Like factoring the denominators is 100% mandatory. So now we can see it for what it really is. And what is the LCD? Right. So it's a pretty repetitive process. Find LCD and then make it. So it's X times X plus 8. So we just go through each fraction and say, what do you need? What's first guy need? Nothing. Second guy needs an X. Third guy needs an X. And so again, we just faithfully perform all the operations. And let's see what we get. We get -1 plus what? 9x squared equals what? 8x. And then our quadratic training kicks in and we remember, just like robots, put it all on one side, set it to 0, factor, solve. So we're going to choose the left side this time because that's where 9x is, or 9x squared is positive. We don't want to wreck that. So 9x squared, and then what goes after that? Minus 8x minus 1. Perfect. And you factor enough, you develop sort of a little sense about this, a little sort of a sixth sense about what to do. The 9 and the 8 are a pretty good clue that this is probably going to be, because you could also do 3x, 3x, but the 8 in the middle is kind of screaming at me that we want a 9 and a 1 somewhere. So shot, I think I'm going to probably want to put ones here, duh. And now the question is, which one gets the plus and which one gets the minus? For sure, we want like this and like this because we want to give a lot of weight to the 9x to make it weigh us down to the -8 in the middle. So these are our two factors, and our solutions then are what? It is -1/9, and our other one is x equals +1. So again, we're just going to take a quick moment and go back to the original problem and just check those numbers, -1/9 and +1. I don't see any issues with that. Neither one of them is going to make a denominator equal 0. At this point in the lesson, you're probably thinking I'm full of it. Like, is this ever actually going to happen? Let's press on. Are you still with me? Okay, good. Let's go again. I'm just waiting for one. I don't have the answers to these in front of me, so I'm just kind of doing them for the first time right along with you. So look, I'm going to take 6x and just put it over 1. Man, we don't want to keep doing that. Equals x over x plus 5. Ooh-ah. No factoring necessary. What is the common denominator? Yeah, and you'll notice I write it down pretty routinely. That doesn't mean you necessarily have to, but it's a good practice to write it down. Hey, fourth verse, same as the first. What does the first fraction need? Second one. So we're going to multiply it. Third one, nothing. And of course, now the whole point is that the bottoms are the same. They go away, and we're left with an equation. -5 plus what? Plus. Yeah, equals what? Nope. And it's just algebra 101. We're going to pile all of our stuff onto the left, set it equal to 0. Let's get this done. 6x squared. How many x's? ¿Cuántos x? 29. Menos 5 igual a 0. This one's not quite as obvious as the other one, unless you know what you're doing. Any spidey sense telling you how to break down the factors? Check it out. What's 6 times 5? 30 is pretty close to 29. That's the math gods telling you that you probably want to go down this road and stick the 5 across from the 6,
Plus,
right?
it's +5.
Absolutely. Just like this.
Big number.
So sometimes the math gods just throw you little clues. Like that 29 was just waving at you, like, do you see me here? I'm close to 30, dude. And so we get our two answers. What are they? Good. And then, of course, as always, we do our due diligence. And for the first time, finally, on example number 4, what happens? -5 is no bueno. -5 is a lawbreaker. So rebel rouser. I think it's rabble rouser. We're going to take -5. And if you put it into either of these denominators, what's -5 plus 5? And thou shalt not divide by, I think it's like number 1 in the 10 commandments of mathematics. Thou shalt not divide by 0, right? And so for that reason, we cross this one off and we go out of our way to box up the one that stays. Every answer at this point now should get one of 2 treatments. Number 1, a box. Number 2, a cross out. Don't leave an answer just buck naked on your paper, because then that makes me feel like you haven't checked it. A box says I'm committed. A check means I'm committed. Like I've checked it and I know if it works or doesn't work. Good. Easy peasy so far? It's not going to, I don't think it gets much harder than this. Okay, you guys care if I skip a couple? Please do, says the young lady. Okay, let me give you this one. Let's see if you think this one's difficult. You little wiser. Ready? I'm sorry. Es un cosa que tengo que hacer. Yep, I'll just go with that. I simply said it's something I have to do. Right. You seem to be getting bored, so I thought I'd up the level a little bit. If we were playing Hades at home, we just upped the heat level from like heat 6 to like heat 11. So what do we do first? Yeah. If you had said anything else, I got to be honest, I'd be a little offended. Let's factor this last one over here. What does it factor down into? Nice. Oh my gosh. Look at that little fellow. So I have an interesting question for you. It's really, that's a lie. It's not interesting at all. What is the least common denominator?
-x plus 5 times x.
Yeah. Listen, that's a really hard question to answer with the current state of this, but because I'm not throwing this at you for the first time, this one in yellow should be sticking out like a sore thumb. What's wrong with it? It's backwards, right? Subtraction backwards can be fixed. You know this trick. So what I'm going to do is I'm going to do a really quick fix. Ready? You see that minus sign? I'm going to change it. You can do this, by the way, same as we have before. I'm going to change it to a plus. And the reason I was able to do that is because the negative that I'm taking out of this, I fed right up in. And now here's some good news for you. We don't even have to consider the negative as part of our denominator anymore, right? So by just fixing the problem up, then I'm good to go like this. So this now becomes the x minus 5. And this is essentially what the problem would have said from the very get-go.
Also, it's not even part of the least common denominator.
It doesn't have to be anymore because we've really just quite literally rewritten the problem like this. And now we can take a clean set of eyes and say, oh, the least common denominator is just one of each. So what does the first fraction need? Yeah. What does the second fraction need? Good. I think this might be my last example. I might give you guys a little work time because I think you're just bored and this is easier than you guys are just too good at math. So great job today. All right, let's finish this sucker up. On the left over here, we get x squared minus 5x. The one in the middle, we just get plus x plus 5. And then the one on the right, we just leave alone 2x. And then we clean up our mess. So let's just stockpile everything over to the west side. What do we get?
Squared minus.
Yep. You scared me. I thought.
Yeah.
Okay,
And up.
job. Nope. And if by some chance, at the end of our third year together, you still can't factor, then I think they should probably walk me out of this place once and for all. So what are the factors? Yeah. So our answers are 5 and 1. And then we just go back up and we see if anyone's a little troublemaker. Anyone cause trouble? The 5 does. The 5's like, hey, look at me. I'm going to make some zeros in the bottoms of some fractions, specifically right here and right here. So for that reason, 5 gets the old crisscross, kabam, and 1 is left as a survivor. So you guys had way less trouble with that than I thought, but I don't know why that should surprise me. So the math is, I know you'd probably just like to be done, but let's work. Let's finish strong. 11 minutes. You have an assignment that just popped up on Delta Math. It'll say like assignment number 34, I think. Let's see if we can knock some of those out. It's a mixture. Some of the problems are embarrassingly simple and some are a little bit harder like this, but nothing to it.
Except probably
We're in a position here where the first fraction, and I know it doesn't look like a fraction, but Lauren's first thing is a 1 over 1. So we figured out that the least common denominator is x plus 3 times x plus 2. What does this first fraction need to be multiplied by? Good, and that's what I wanted to talk about is we actually don't want to multiply it by x plus 3 times x plus 2. We want to multiply it by x squared plus 5x plus 6. If you multiply it by x plus 3 times x plus 2, it's not a bad thing. It just means you're going to have to multiply it back out in a minute anyways. So it's best to take the unfactored version of that quadratic when you're going to sling it back in. Does that make sense? Rad. Okay. And then what does the second fraction need? And then the third fraction doesn't need anything, right? Is this all looking like what you got? So yeah, so that's probably what happened was you still had like an x plus 3 times x plus 2 maybe. Yeah, so you want to sling it back in as a big like, because we're going to wind up having to combine like terms, so we want them kind of out in the open. So you want to finish? Okay, so we're going to get x squared plus 5x plus 6 minus 7x minus 14. You with me? And then we're going to get x squared minus 2x minus 15, I believe is how that math all checks out. Combining your x's and then moving the 7 over and combining all, I think you wind up at this. So then now it's time to factor again because we need to expose our answers. So what are these going to be? I think we're going to want to do minus on the 5. Like that, just to make sure it balances correctly. So your answers are going to be 5 and negative 3. The negative 3 makes bad things, right? Yep.